My name is Nicholas, and I'm presenting this work done with Marco Janssen and James Collofello. We're here at Arizona State University. And it's also on the topic of open source. So if you don't like open source, you can be bored for a while longer here, especially since I have some similar information that was just covered. So I'll try and go over that a little bit faster. What I'm looking at is understanding the free Libre open source software development process using agent-based modeling. So basically, as he mentioned, free and Libre open source software is a licensing issue. Okay, basically, it says that the source code is going to remain open in one way, shape, or form. Although there are possibilities for taking it, modifying it, and closing it up depending on the license. But the point is, when it's released under an open source license, this source code has to be available. And so that gives other people the availability to essentially take the code, modify it, and use it to their own liking. When you talk about free or Libre, there's some confusion. It's not free as in cost, okay? It's free as in liberated, and free as in speech, freedom. All right? It's referring to the fact that the code has to remain available for other people who want to, in fact, use it. It's as old as computers essentially are, although the last 20 years is when we've really seen it more or less defined. And it's been gaining popularity in the recent years. Everybody has interacted with open source at one point in their life. Everybody's probably heard of Linux. That's probably the most famous open source that you can come across. But the internet is absolutely full of open source projects. Every time you're surfing the web, 2/3 of the sites are being served up by the Apache web server. That's open source. Anytime you send email, all right, the famous routing software is SendMail. So chances are, if you're sending email, it's being done through SendMail, which is another piece of open source. DNS lookups, all those sorts of things tend to be open source based. So there are a lot of positive characteristics of FLOSS which make it worth studying. Particularly, in some cases, it produces rather high quality software with low defect counts. In fact, in the case of Linux, there have been some studies that essentially say it doesn't get any better than this. This is so much further better than commercial software in the industry for operating systems. I mean, it's ridiculous. It's mind-boggling how good it is from that standpoint. Rapid development, violating Brooks' law. Again, the concept that's pretty well understood in proprietary software is if you throw more people at a late software project, it gets later. Okay, versus in open source, you throw more people at it, and it gets faster. So something strange is going on between what you're seeing in closed source and open source type development. And it's become serious competition for commercial software. And of course, everybody likes the fact that it's typically free to get, free to use, free to modify, or free to redistribute. But of course, we're talking about successful instances. Okay, everybody's heard of Linux, and everybody knows that's successful. But for every single successful instance of open source, there are dozens, if not hundreds, of cases where something has been released as open source and it dies. It gets abandoned. Nobody's working on it. And in fact, this is a major concern. People who are looking to adopt open source, especially things like governments or organizations, or even for personal use. You know, what assurance do they have that this piece of software is going to continue in development and be around in the future? Very interesting question. So what we're trying to look at is partially, can we look at the success of open source projects, but in general, what can we learn by modeling open source using, for example, agent-based modeling? Can we gain some insight into any of these sort of things? So, here's kind of the background of what separates this model from some other models of open source that have been done. We're looking at simulating across a large landscape of projects, okay? Because essentially there are literally hundreds of thousands of these projects out there. And we're not concerned with what it is that motivates people to contribute to open source in the first place, okay? Clearly there are developers out there, clearly they want to develop. What we're interested in is if they have all these to choose from, which are they going to choose, okay? Because that comes back to the question of, if you can attract developers to your project, chances are better that it's going to be successful. Obviously, if you can't attract anybody, it doesn't have a very good chance of gaining any momentum and producing any software with any level of utility. This is not a social network type model. Some of the models focus on the social network that you see within the community of developers. It's done with agent-based modeling, and as already pointed out, SourceForge and a number of other repositories are available for data for calibration and validation purposes. Now, one of the problems that you have with open source, again, is it violates some of the norms in regards to how you judge if something is successful. In closed source, there's some pretty standard metrics that people use. They say, for example, the software on budget. Is it on time? Does it meet the specifications that the customers came up with? Are the customers? Are the customers satisfied? Unfortunately, those don't apply particularly well in open source. There is no budget on time. Well, there's not really a schedule. And it's actually been shown that normally open source isn't even using what we would consider formal specifications to specify what the software has to do. So people have come up with a number of different metrics that potentially can be used in the case of open source. One is just to look at, did the project get completed? Looking at its progression through maturity stages. It starts in a planning stage, moves eventually to a beta stage, mature stage. Number of developers involved. Again, with the notion if you can attract developers, maybe it's a successful project. Level of activity, anything, email traffic, bug fixes, any of those kinds of things. Looking at the time between releases, the notion is that you need to be creating releases relatively frequently in open source in order for it to be successful. Developer user satisfaction, how many users do you have, those sorts of things. So I can split factors into two different kinds of categories. Technical factors and social factors. Technical factors are very easy to measure and they're objective. They're the kinds of things that we can get from the repositories. The things like how many lines of code, what's the programming language, do any of those sorts of things affect the project itself, how many developers are working on it. The social factors are much harder, okay, they're hard to measure, they're subjective. Examples would be reputation. Are developers choosing open source projects because they think that this project will boost their reputation in the community somehow? Are they simply choosing something that interests them, okay? Or does that not matter as much? They're just interested for other reasons. So what are the reasons that people are contributing? And so fortunately we can look at some of the theory on public goods domain and, for example, why do people cooperate to begin with. So here's a description of the model. Okay, I'm going to kind of go through this relatively quickly. There are agents and projects, okay, and the agents can either be consumers or producers, or if you prefer, consumers are users, okay, the people who are using the software, producers are developers of the software. And essentially these agents are free to choose projects to download or to develop for. At any given time step, they can be working on nothing, they can be working on one thing, they can be working on multiple projects, all right, depending on what they choose to do. We set a time step up of T equal to a 40-hour work week. At the beginning, we kind of we seed this with a bunch of projects and a bunch of developers. So we track a number of properties with agents, since this is an agent-based model. We have a consumer number and a producer number. Basically, these are propensities of an agent to either consume open source or produce open source. For example, if it's 0.3, it says that 30% of the time that agent will either consume or produce, depending on whether or not it's the consumer or producer number. Resources number, the idea is that each agent has the ability to contribute some level of resources or some amount of work to projects. This has been normalized to a 40-hour work week. And if you excuse me, look there on the right-hand side, well, there are actually some surveys that have been done. How much time are people contributing? You can see that the bulk there are people are contributing between 2 and 5 hours a week working on open source. Okay, remember, this is still mostly volunteer-driven, although some people are in fact paid to work on open source. Agents also have memory, so they don't know about all the projects in the simulation. They can know about some subset of them. That's pretty realistic. Then finally, we have this concept of a needs vector. The idea is that every agent is potentially interested in certain kinds of projects. This agent may be interested in business applications, another may be interested in games and networking. So we abstract this idea into essentially a vector of values between 0 and 1, and use this to say this represents the interest of the agent. Okay, the projects also have some properties that we keep track of. The reason, so when we create a project, it has a certain final size that it has to be. This could be a small project, or is this going to be a big project? Current resources, that's how much work is actually being done by the agents who are currently working on the project. Cumulative resources, how much work has been done up until this point since the beginning of time. Download count, very obvious. How many times have agents chosen to download a project based on being interested in it. And projects also have a needs vector. Okay, same sort of concept. It represents what are the interests of this project, what direction is this project going in. Agents have static needs vectors, but projects essentially are influenced by the agents who are working on them. So that equation there is basically showing you It's a decaying equation. The first term says how much of the project's direction is based on the project's direction from the previous time step, how much is based on the current time step and the people who are contributing at this point. The idea being that an agent who's contributing a lot has a large effect on the direction of the project. An agent who's contributing only a little has a very small impact on the direction of the project. Finally, we're tracking maturity stage. Essentially, a project can go from planning to pre-alpha to alpha beta stable, and finally, if it's lucky, it'll survive and get to a mature stage.